All right, hi Math Transitions class. This is going to be week 4, notes and homework. I hope you all are staying safe and still doing all right. Remember to reach out to me if you guys have any questions or anything about what we did for the week. So you can email me or send me a remind text. And we also have the Google Hangouts on Fridays, which is a video chat. You don't have to be on video camera if you don't want to. You can type in those Google Hangout chats too, and you can turn your camera off, so you don't have to be seen if you don't want to. You also can just join the chats and just listen along. You can turn your mic off and mute if you don't want to, talk. You just want to hear what everyone else is saying, so you can do that too. So we have those on Fridays, and then you can email me, like I said, or send me a remind text. Before I start these notes, I just want to remind you guys too that I need to see your notes and your homeworks either submitted to Google Classroom or sent to me through Remind or emailed to me. So I need both. If I don't get both by the end of the week, I'm going to have to mark one of the two as missing if you don't send it to me. And the new rule that I implemented this past week was that I need to see your name clearly at the top of your notes and your homework. Okay? All right, so let's get started on these factoring notes. So factoring, we're going to start with this little warm-up here just to show kind of how we're going to be working backwards. So if you were to just simply solve these by simplifying, all right, when you see something in front of a set of parentheses and it's right outside, that means you're going to multiply. So you're basically distributing the a to the 3a and the 7. Well, if I multiply a times 3a, that gets me 3a squared, and then a times 7 is a positive 7a. All right, so this is working forwards, and what we're going to do today is work backwards after this. So here, you're multiplying it by 3 terms inside of the parentheses, so negative 2m times m squared, remember you add the exponents when you multiply, would be negative 2m, now we have 3 because there's a 2 plus a 1, so negative 2m cubed, and then negative 2m times positive 6m would be negative 12m squared, because you have m to the first and m to the first, so that equals 2. And our last one is negative 2m times a negative 1, which changes it to positive 2, and the m just stays right after the number because there's no m attached to the negative 1. So this last one is distributing a 4x cubed y. Don't want to miss the y there. And you're multiplying all of that by 2 terms inside the parentheses. So the 4 has no number to multiply in front of that x, so that's going to stay a positive 4. But our x terms, there's x to the third times x to the second, so we're going to add those exponents and get x to the fifth. Now the y has no y that it's being multiplied here, so it's just going to stay on the end as y to the first. Now the second thing we're multiplying is a 4 times a negative 2, which gives us negative 8. The x to the third has no x after this 2 to be multiplied by, so it just stays x to the third. And the y times a y, that's basically y to the first times y to the first, becomes y to the second. Okay, so this is simplifying by distributing through multiplication. Now what we're going to do in these notes and homework is called factoring. So factoring is you're working backwards. All right, you're going to be separating a polynomial back into a product. So again, working backwards. Okay, so simplest form, after you would do what we did in the warm-up, my example I'm going to give you, this is just one that I made up, would be 4a squared plus 8a. Okay, so this is simplified. Factoring, getting it back to factored form is, like I said, working backwards. So what this would have started as, before simplifying, is 4a times a plus 2. So in our warm-up questions, you started with this, you multiplied to get this. So what we're going to talk about is how do you factor? How do you work backwards and get back to the original product? There will be a case sometimes where you can't work backwards. There's nothing to be factored, and those are going to be called prime polynomials because you can't factor them, okay? So the next couple things that are in these notes, which, you know, would be a lot easier to just photocopy and give to you in class, but obviously we don't have that option right now, is just some steps, okay? So if you need to pause the video, this would be a good time to pause it because I need you to copy down what the steps are, all right? There's no fill in the blanks. It's just all laid out for you right here. So I'll read through it quickly and then you can just pause it or rewind whenever you need to. But there's several factoring methods and the approach just depends on the polynomial that you're given. So we're going to start by identifying and then factoring out the greatest common factor. So that's the method we're using in these notes is factoring. We need to find the greatest common factor, which is the biggest term that's going to go into everything in the polynomial. So the first step is going to be identify what that greatest common factor is. Check the coefficients. So the coefficients are going to be the numbers that are in front of the variables. Okay, so if I write 2a, all right, the 2 is the coefficient. Okay, the number's in front. Now you look at the variables. Okay, the variable, if it's part of the greatest common factor, the variable must be present. So a variable is any letter. For example, the letter x. It's got to be present in all the terms in order to be part of the greatest common factor. If that variable is present in all the terms, you take the one with the smallest exponent out. Okay, we're going to factor it out and put it out front, okay, which you'll see when we get to our examples. All right, divide each term by that greatest common factor and leave your answer, or whatever remains, in parentheses. And then you could always check your work by distributing. So if you were to factor something out and you just want to double check your work, you could always go back the other way and distribute. See if you get what you started with, okay? All right, let's do some examples here. It says factor each polynomial, check your work by distributing if you want to. If that polynomial can't be factored, then you're just going to write prime. So if there's no greatest common factor to take out, then it's a prime polynomial and there's nothing you can do with it. So in this first example, let's look at the terms we have, a 3x and a 12. Okay, well, what's something, letters, numbers, or combinations of letters and numbers, what's something that will go into both of these? All right, well, I can see right now that the 12 doesn't have an x. So I know a variable is not going to be part of my greatest common factor. What I do see, though, is that both of these numbers, the coefficients, are divisible by 3. So our greatest common factor, I'm going to write down as a 3. Now it says to divide each of those terms by that greatest common factor that you picked out and leave what remains in parentheses. So I'm going to start my parentheses. Now if I wanted to get 3x by multiplying 3 by something, what would that be? Well, 3 times x gives you 3x. So what remains, I'm going to put in parentheses. Now, how do I get from a 3 to a 12 using multiplication? Well, you would multiply that 3 by a positive 4. Okay, and if I were to close my parentheses and then check my answer, I could just distribute the 3 back to everything inside the parentheses. 3 times x is 3x, 3 times 4 is 12. So that means you factored it correctly. Now the next one, number 2, is also just as simple. The only thing we're going to be able to factor out here is a number because these two terms don't both have a y. So I can't pull out the y into my greatest common factor. They both are divisible by 7 though. So I'm going to pull the 7 out front just like I did the 3. Start my parentheses because my greatest common factor is just 7. How do I get 7y from 7? Well, you would multiply that by y. How do you get a negative 7 from a positive 7? If you multiply it by negative 1, 7 times negative 1 will get you negative 7. And then you can close your parentheses once you've gone through each term. Okay, so 3 and 4. All right, we've got some more letters. We got one more letter. But let's look at what we have in number 3. All right, this term has an M, this term has an N. So they don't have the same letter. We can't pull a letter out front. But both of these numbers, the coefficients, are divisible by 4. Okay, so we can pull that number 4 out and then see what's left over to get us back to the original. Now, what do I multiply 4 by to get 8m? Well, 4 times 2 gives me 8, and this 2 would need to have an m in order to get an m after you multiply. 4 times 2m gives you 8m. Now I'm going to put a plus sign in the middle because a positive times another positive will get me a positive number. What times 4 gives you 36? Well, that's 9. But what times 4 gives you 36n? 9n. You can close parentheses. Okay, number 4, same thing. We've got two terms, but they have different letters. So I can't pull out a letter in front of the parentheses. But I can see that both of these numbers are divisible by 5. So what times 5 gets me 5x? Well, you just multiply by x. What times 5 gives you 30y? It would be a positive 6y. Okay, if the y is not going to be out here, the y would have to be in here, just like the x. If I can't pull out the letter, it's going to have to be in here. Okay, now on my second page, I have circled some examples because I don't think we need to do another 21 examples, starting with number 5 and going all the way through 24. If you want to do some of these examples on your own, you could always pause the video and copy these down and try them out. And then if you have questions, you can ask me throughout the week. But I just wanted to go through a few more just so you can get the idea. And then again, if you still have questions, please reach out. But I circled number 5. So in number 5, okay, we have 6a squared plus 27. So we have to factor that out. Well, these two terms don't both have an a. Only the first one does. So I'm going to have to pull out a number that goes into both 6 and 27. The biggest number that does that is a 3. That's our greatest common factor. So now we have to start our parentheses once we've identified that. What times 3 will get you 6a squared? Well, 3 times 2 is what gets you 6. To get an a squared, we're just going to have to attach an a squared to that 2 because the 3 that I pulled out has no letter a's. All right, so let's do a plus sign because somehow we have to get from 3 to 27. Well, all you have to do to multiply by 3 is use a 9. And then you can close parentheses. So that is that polynomial factored out. All right, let's go below that to number 7. That's the next one I have circled because we can pull out a letter in this example. So both of these terms have the letter D. Okay, so we can pull out the variable D, and then 21 and 3 are both divisible by 3. So since both of these terms are divisible by 3 and the letter D, I'm going to pull out 3D. Okay, and then we'll start multiplying and work backwards. So what times 3 would get me 21? Well, that's a 7. But I don't want to just get 21, I want to get 21CD. Okay, so 3D times 7 something has to get me this. Well, I don't have a C out here, so I'm going to have to multiply by a C if I want CD in the answer. I don't want to write down a letter D after this because if I take 3D and multiply it by another term with the letter D, then I'm going to get at least D squared, and I don't want that. So I'm going to move on to the minus 3D. Well, what times 3 would get you negative 3? Negative 1. And that negative 1 is going to stay just as that number because I want to end up with 3D, no other exponents, no other letters. So that one's done. Okay, I'm going to go down to number 12 because we have multiple variables here. So we have x squared y and 3xy. Okay, so what greatest common factor can I take out from this polynomial? Well, they both have an x, they both have a y. Okay, but what number goes into, technically this is a 1x squared y. What number can I take out? Well, if my coefficients are just a 1 and a 3, then my greatest common factor is going to be a 1. Okay, because 3 doesn't go into 1, even though 1 goes into 3, the highest number I can take out is a 1. So if I look at the exponents, our rule said to look for the smallest exponent, and that's going to be a 1 for the x's, and a 1 for the y. Okay, both of these terms, if I look at the lowest thing that I can take out, it's x and a y. So I'm going to write an xy out front. That's my common factor. start my parentheses. What do I have to multiply xy to get x squared y? Well, remember, when you multiply variables, you add the exponents. So what would I add to 1 to get 2? Just another 1. Now, if I only want to end up with 1y, okay, I don't want to multiply any more y's because it's already 1y. So this is going to stay x. So what would I multiply xy by to get 3xy? Well, that would be just a 3. Okay, remember, you can always double check by distributing. Make sure you get back what you started with. And when you multiply variables, you add the exponents. So this would get me my x squared in the first term and y to the first. Okay, let's do 2 more, because number 13 and 14 are the last 2 I have circled. Now, if I look at 13, okay, we've got 2 different letters, so we can't pull out a letter. And the numbers, the coefficients are 5 and 13. Well, what's the greatest common factor, the biggest number that will go into both 5 and 13? Well, the problem with 5 and 13 is that they're prime numbers. So the only numbers that will go into them are themselves and 1. Okay, 5 won't go into 13, 13 won't go into 5, so the only common factor they have is a 1. If you guys multiply anything by a 1, it's not going to change what you have. So this one is a prime, because there's nothing we can take out that we can factor out and then multiply some stuff in the parentheses and have anything different than what we started with. So it'd all be pointless if we tried to factor that out. Last one's 14. So 14 has 3 letters. It's got an A, B, and C, and they both have A, B, C. So the term that I factor out is going to have an A, a B, and a C. So let's look at the numbers in front. What is the biggest number that goes into both 18 and 48? The greatest common factor is a 6. Okay, so let's look at the letters. Take the exponent that has the smallest exponent for that letter. Well, the smallest exponent for an A is A to the first. The smallest exponent for B is just B to the first. And the smallest exponent for the C's are C squared. Okay, it's the smaller of the two. We've got C squared and C cubed. So this is our greatest common factor right here, 6ABC squared. So now we have to multiply. So what would I have to multiply this by to get 18a squared bc squared? Okay, well, 6 times 3 gets you 18. Okay, a times a would get you a squared. We want this to stay as b, so I'm not going to multiply any more b's. And then we want this to stay c squared, so I'm not going to want to multiply any more c's. So this is just 3a. We're going to multiply something by 6 to get negative 48. So I know that's going to be a negative number. 6 times 8 is what gets you 48. So let's look at the letters. All right, we want the a to stay a to the first. So I'm not going to multiply any more a's. We want b to stay b to the first. So we're going to not multiply by any more b's. C squared, we want to be c to the cubed. So, or c cubed. So we only want to add one more exponent to that, which means just c. Okay, so that'll get you back what you started with. All right, so you're working backwards by factoring. You're factoring out the greatest common factor and putting that in front of your parentheses.